You know, objects-oriented programming, or OOP. It can sound pretty intimidating, right? But at its core, it's really just about solving problems in a more organized, human-like way. Today, we're going to break down 3 of its biggest ideas: abstraction, interfaces, and polymorphism. And we're not just going to define them. We're going to get to the bottom of the problems they solve and really see why they're such essential tools for any programmer. So, let's get started.
Just think for a second about your favorite app. It's probably jam-packed with features, right? And yet it feels simple, almost intuitive to use. Well, that feeling of simplicity, it's no accident. It's all about wrangling a ton of complexity behind the scenes. And the core ideas we're about to cover are exactly how developers manage to pull that off.
So, let's start with our first big idea: abstraction. At its heart, this is our main tool for creating that simplicity we were just talking about. It's all about hiding the messy, unnecessary details to make things way easier to work with. A perfect real-world example of abstraction is the smartphone you're probably holding right now. You just tap on simple icons and buttons. You don't need to understand the complex circuits, the radio signals, or the millions of lines of code firing off underneath. The phone abstracts away all of that complexity, showing you only what you need to see to get the job done. That's it. So what does this look like in actual code? Well, we can create an abstract idea, kind of like a blueprint, and call it vehicle. Now, this blueprint isn't a real, drivable vehicle. Instead, it just lays down a rule. Hey, any real vehicle must have a way to start. It defines the what. Then, we can create a real object, like a car, that follows that blueprint and fills in the specific details, the how. For a car, starting means turning a key. Simple as that.
All right, so to wrap up abstraction, the big thing to remember is this. It lets us separate an object's essential behavior, the what it does, from its complex inner workings, the how it does it. And this focus on the what over the how is absolutely fundamental to writing clean, manageable code.
Okay, so abstraction is great for hiding complexity inside a single object. But what happens when we need different objects to talk to each other reliably? How do we guarantee they can actually work together? Well, that's exactly the problem that interfaces are designed to solve.
An interface is, for all intents and purposes, a strict contract. And the USB port is a fantastic way to think about it. The port itself doesn't know or care if you're plugging in a mouse, a keyboard, or a webcam. It only cares about one thing. It enforces a standard. If you want to connect to me, you must have this specific shape. That's what an interface does in code. It defines a set of rules that guarantees different things can connect and work together, no questions asked.
So in our code, we might have a payment interface. This interface acts as that contract, basically declaring that any class that claims it can handle a payment must have a pay function. This lets totally different classes, like credit card or UPI, both agree to the contract. And even though they both have a pay function, the internal logic for how they actually process that payment can be completely different, and that's totally okay.
And that right there is what makes interfaces so incredibly powerful. They create what programmers call loose coupling. All that means is that the part of your app that handles a payment doesn't need to know any of the specific, messy details of a credit card or UPI. It just knows it as a payment object, and that object can pay. This makes it super easy to add new payment methods later without breaking any of the old code. It's scalable, flexible, and so much easier to test.
Okay, so this is a spot where a lot of people get tripped up, so let's make the difference between abstraction and interfaces super clear. Abstraction is all about creating an is-a relationship. A car is a type of vehicle. It's focused on the object's identity and hiding its internal complexity. An interface, on the other hand, is about creating a can-do relationship. It defines a capability. A credit card object isn't a payment, but it can do the act of payment. So one is about identity and the other is about ability.
All right. Now that we've got a handle on hiding complexity with abstraction and defining contracts with interfaces, we get to the really cool part, the payoff. And that payoff is polymorphism. Now, don't let the fancy name scare you. It's not some brand new, complicated concept. It's actually the powerful, flexible behavior that just naturally happens when you use the first 2 ideas correctly.
The word polymorphism literally means many forms. And in programming, that's exactly what it is. One action having many different outcomes. Think about a play button. The action is always the same. You click play, but the result totally depends on the context. In a music player, a song starts. In a video player, a movie rolls. See? Same action, different outcomes. That's polymorphism in a nutshell.
So here's where it all connects back to abstraction. Let's say we have our abstract animal class. From that, we create specific animals.
like a dog and a cat. Now, because they both share that animal identity, we can treat them both as just generic animals. But here's the magic trick of polymorphism. When we tell each animal to make a sound.function, the program is smart enough to know which specific animal it's dealing with. The dog barks and the cat meows. Same instruction, totally different behavior. So, how does that magic actually happen? It's really a simple three-step process that happens when the program is running. First, your code makes a general call, like animal.sound. Next, the system looks at that animal and checks what type of object is actually stored in there right now. Is it a dog or a cat? And finally, it executes the specific sound method from that actual class. That's all there is to it.
So, the bottom line with polymorphism is that it lets us write much more general and flexible code. We can call the exact same method on different objects and just trust that the correct specific behavior is going to happen. And this is all figured out at runtime, which just means while the program is actually running. And that's what makes it so incredibly useful.
We've broken down these three big ideas one by one. But you know, their real power, their real magic, comes from how they work together as a team. They help us build software that's robust, flexible, and just plain clean. So let's bring it all together.
Let's zoom out for the big picture. We start with abstraction to hide complexity and just simplify our designs. Then we use interfaces to define these rock-solid contracts so our different objects can communicate reliably. And finally, polymorphism is the amazing result of that structure, letting us write flexible code where the same action can have totally different behaviors.
So if you're going to remember one thing, remember this. Think of it this way. Abstraction is your tool for good design. Interfaces are your tool for building a scalable system that can grow. And polymorphism is what makes your code flexible enough to handle different situations. You master these three, and you are well on your way to writing clean, professional, object-oriented code.
Okay, so to really make these ideas click, here's a little challenge for you. The next time you're using your favorite app, just pause and ask yourself, where are these concepts at work? Where is complexity being hidden from me? What kind of contracts do different parts of the app seem to follow? And where does one button do a bunch of different things? Spotting these patterns out in the wild is truly the best way to master them. Thanks so much for joining me.